Alrighty, so we got our screen here. We got it all pulled up. Let's go ahead and start ourselves off with the usual as folks start to trickle in. How's everybody doing? We have looks like we got a few people here, but this is the very last, the very final Spatial Viz workshop. You have done it. You've made it through, or at least nearly there. I hope the sad face is because you loved it so much and not because you have to go through another Spatial Viz class. No, I'm just kidding. I think that it's been an enjoyable workshop to teach, and it seems like, based on, just being able to interact the way that we do in this, I really appreciate it. It's a lot of fun. So go ahead and throw some drawings up there. Throw up a slightly disgruntled face like three other folks have done, and get it out of your system. We'll start drawing on there. Just get ready to participate, and then we'll move on. So today, again, is the last Spatial Viz workshop. That means that if you have 5 assignments turned into Canvas right now, then you are on track for, you just need one more assignment in here to finish off and get that 3% extra credit. If you have, if you plan to take the test again, you'll need to, each test retake requires 3 assignments, right? That's kind of the deal, right? So if you do 3 assignments, like 1, 2, and 3, you are eligible for the retest the first time. And if you do 5, 6, or 4, 5, and 6, you get another attempt at that, right? So if you have not achieved 20 out of 30 or greater, then that'll be your opportunity once we finish this. So let's get going on this. I'm going to clear the screen right here. We've got lots of great stuff. While I clear the screen, if you wouldn't mind turning on your cameras, if you have the ability to do so, I'd sincerely appreciate it, and we will get going. Today, we're jumping into week 6, flat patterns and games. I don't want to necessarily get anybody too excited, right? The games are kind of like study games, right? How do you prepare for this aside from doing the, practice tests and stuff like that? But you'll see how that turns out here in just a little bit. So flat patterns. This one is honestly one of my favorites because it's, I don't know, there's something about flat patterns that is pretty fun, right? It's kind of like origami, except in origami you're not supposed to cut pages, right? Or glue, right? So it's not at all like origami, but it's folding paper, right? So we're going to be effectively, well, what do you think? What do you think flat patterns means? What are we going to try to do in order to create a flat pattern? Any suggestions? Oh, we got chats. Let's see. Unbox a box. Very good. Nice. I love it. Right. We're going to unbox a box. So thanks, Maxine. We've got our shape that we normally start with in most of these examples, right? And effectively what we're going to do is it's like turning it into, well, in CAD, we usually call it sheet metal, right? Because sheet metal is not crumply like paper. It's nice and static. It doesn't really matter what it's made out of, but you get the idea. When we start from a flat pattern, we have a tool called sheet metal that can bend it up into its shapes and pieces, and we get our kind of 3D model that's hollow, made out of kind of a flat sheet of something that's not infinitely flat, but has a tiny bit of thickness to it, right? And that's really what we're doing. So let's, as usual, go through the things that you should maybe be looking out for, and then we'll move on into kind of playing with it together, and then we'll finish it off with some instructions on how to do the homework. So first things first, if y'all will grab a red pen. I specifically say red pen just because we're going to be changing colors here in a little bit. So if you'll grab a red pen, and if you will please help me identify where this face is on our flat pattern, right? So if we were to translate this over to here, which of these faces or which of these sections of the flat pattern are reflected by this red side over here? Aha, we got a squiggly, right? Very good. So we got this red L shape, right? How do you know? Well, we know that it's this one and maybe not this one, right? It looks like this one is correct, at least close to being correct, right? Because it is an L shape, but there's kind of this extra, you know, making it a little bit thicker in the kind of sideways jog of the L, right? Whereas this side is really, let's see, oh my goodness, that wasn't my, that's why I'm trying to erase everybody's, or this one over here, right? This is our L shape because it's the only, let's see, 1, 2, 3 by 2 shaped L, right? Everything else is normal. So how about this yellow one? Let's take a look at that. Where does this yellow shape go? It looks like there's a couple of 1 or 2 by 2 L shapes, right? We had the single 3 by 2 L. We identified that one, but which one of these is this one particularly? And how can you tell? What is your, aha, okay, so I saw a little dot. Okay, very good. So we got yellow showing up here on the bottom one. Why not this one? Why is it not this one, would you say? Well, again, this is kind of the preview of how we're doing this, right? So I won't belabor that point too much, but right, if this face is kind of bent from, you know, right here, right, and we bend it over like this, the edge, we kind of make a flange. You'll notice that this bend, right, for this little tab right here, right, is supposed to be in the same direction, right, as this bend, right? It's might be up instead of down, but it's not, you know, a jog to the left or anything like that, like this one is, right? So that's one way that we can identify that this one is not correct on the top, but in fact, what everybody was pointing to on the bottom is correct, right? This bend right here is in the same direction as this bend right here, right? Let's see. So we get that one right there. So that's very good. Let's make sure that we did it right. Look at that, sweet. And then lastly, let's just identify one more. This one, where does this one come from? Well, we already kind of talked about it a little bit, but somebody go ahead and throw that blue square up there. Right? It's not attached to the one that we just had, right? Because that would be this one, right? But the one that we were talking about before, right, which is kind of, you know, this fold is in the opposite or perpendicular direction to this fold, right? Which shows up here, right? This fold and this fold are in opposite directions, whereas this fold and this fold are in the same direction. Right? Okay, and so when we double check and check it out, there we go. We got our blue shape up in that corner. So this is more just kind of like the identification, right? What is it going to look like? What are these faces? How do they match up and whatnot? But let's actually talk about this, right? Because one of the things, one of the activity options, at least in this week's activity set, is going to be actually taking a piece of paper and drawing out the flat pattern for, I'm going to give you a catalog of all of the shapes in the test, right? Every single one. Actually, you've had access to those this entire time, right? They're on the little Onshape, right? You can go to these Onshape icons in my slides, or you can go to the extra resources, the additional resources in the Spatial Viz Canvas course, and you can find all of the, you know, Onshape items of all of the shapes. But I'm going to give you those, and I'm going to ask you to make a flat pattern of some of them and actually cut them out and tape them together, right? And so just a few things that kind of go into that, right? You start off with this big sheet of paper, and you might draw an outline, right? You got this kind of, you know, maybe you've done this with a cube before, right? And you have this kind of flat thing with 6 squares. They're kind of all in a line, and then you know where they need to fold. Well, the thing is that, well, a cube is only going to need 6 mountain folds, right? And I say mountain folds because whenever you bend it down, well, it kind of makes a mountain, right? Now, arguably, if you flipped it back over, it's a valley. But so the main idea here is that a mountain fold only exists in the company of a valley fold, right? But the idea is to say that a direction indicated by the style of line showing the drawing, right, the drawing edge, is going to tell whether or not that edge gets folded up or folded down, right? And so these are the 2 terms that we use, mountain fold and valley fold. We're going to use a dashed line for mountain folds in blue. You might not have colored pencils, so I chose a different style, a dotted line in red. And then, of course, cut edges are solid in black. So let's play with this, right? I talked about a cube earlier. Let's do something a little bit less boring, but still actually kind of maybe a little bit boring, right? It's a rectangle. It's an extruded cube, right? Okay, sure. So how would we start with this? What would the flat pattern of this look like? Somebody want to help me out or start drawing, right? There's actually a rectangle in the draw menu. There's a rectangle tool, right? Where you can draw perfect rectangles if you wish. Hint, hint, I think that that's a useful one. But what do you think? What should we do? Okay, so we've got this blue rectangle that has appeared suddenly, right? And okay, so let's say that this face is this face, okay? And we've got somebody drawn a purple face or a purple edge right here. We got that, oops, right here. Somebody has drawn a blue square right here, right, to indicate this. So we're kind of going back and around with the purple edges, right? Effectively, how many shapes do we need? Well, we need, okay, beautiful, 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 beautiful. We need 6 faces, and these 4 faces need to be all conjoined along their long edge, right? I would argue that that's kind of the indication of how these are mated together, right? How these faces are joined together is that they are joined along their long faces, and then you know, these cubes, right, or I'm sorry, these squares are joined along one end of one of these squares, right? And it could be down here too, right? I don't necessarily need to be all in a line. In fact, I could do something like this, right? I could modify somebody's drawing and make it something like this, right? That being said, what is the difference? What do we need to do in order to account for the fact that this is partially true, but when I was talking last time on the last slide, right, that cut edges are solid, where do we need to invoke you know, dotted lines versus solid lines? And I'm going to suggest that you use the draw tool with the white marker, right? I'll give this one, right? We know that this needs to be dotted, right? Because this kind of folds down and over. Right? So where are the other fold lines, right? As opposed to the cut lines that we have? Because right now, right, this would be a separate shape. Okay, it looks like we got some down here next to this other cube, right? Then I'd also argue that maybe we have one right here, and right here, and right here. Right? Yeah, beautiful. Right? Good. And we can check on that real quick. Oops. Yeah, okay. Looks something like this, right? Where we have these dotted lines filling in this, this folding pattern, right? Very uneventful, right? We only have one type of folding pattern, right? But before we go too far, right, I want to actually open up this Onshape thing, right? And I want to take a look at what it looks like to use the sheet metal tool in Onshape, right? And you might be interested in this. You might just kind of use it as a tool in Spatial Biz, but that's fine. But let's take a look. So I'm going to take a long rectangle, right? So this is a 2 by 1 rectangle, okay? And if we extrude it out 1 unit in one direction, not the boy band, you'll notice that, so we have a pretty standard, cube. And then there's this tool up here called sheet metal model. So what we actually do is we start with a 3-dimensional model, right? Something that has thickness and has a solid body, right? And now we choose to turn it into a sheet metal model. Now, while we're doing this, this is kind of, we have some stuff to do, but I want to bring your attention over to this tab over here. When I start a sheet metal model, this tab opens up and I can actually start to see the different pieces of sheet metal that get populated as part of this, right? So I have 1, 2, 3, 4 of the long rectangles and then 1, 2 of the short ones. So the next part is that I need to select the edges that I want to mend together and therefore bend, right, through a bend. So if I select this edge and this edge and this edge, right, then all of those together are going to create that kind of long rectangular piece that we had before that was bent into sections, right? And that's exactly what we had here, right? So that's no surprise, but now when we add these wings, right, I want to see something real quick. So if I were to say add a wing right here, a bend in this wing right here, on one of the ends, so it's kind of coming off of this end piece. What happens if I try to do this? Why does it say the sheet metal model cannot be unfolded? Can somebody help me determine why I can overdo this in the sense that when I mend these two pieces together in one bend, why can't I unfold them? It breaks everything. You can feel free to unmute yourselves if you just want to. Okay, we have it. Let's see. You have a single sheet that you are trying to bend 2 ways. Very good. Okay, yes. Thanks, thanks, Brendan. Exactly right. We can see that if we have this corner, it's almost like we've taken 2 flaps at a corner and then we folded them over each other and glued them together. Right. It's kind of impossible to get one sheet overlapping like this, especially when we have thickness. Right? So, and we would have to cut this edge in order to pop it open. Right? So that's one thing to consider when we're generating something like this. And then I can finish it out with something like this. I don't know. And when we finish that off, you can see that I have my part. It's made out of sheet metal and it was generated by, this flat pattern. Right? So that's a kind of a fun tool, and we'll continue to use this here in a little bit. But let's say with this part, I add this feature. I've got this kind of green outlined feature it's another rectangle of the same, a rectangular extrusion of the same size, right? That I've tacked onto the back, right? So first off, what would need to change about this? At first I had, let's see, when I first drew it, I had 4 of the long rectangles and 2 of the squares, right? Square sides, so that's these 2, right? How many squares do I have once I incorporate this thing, and how many long rectangles? Let's start thinking about that real quick. I'll give you a minute to look at it. You can write it over here on the other side of this rectangle like this. Times blank and blank. How many of each are we going to have? So looking at this thing, right, I've got my rectangle that from before that had 1, 2, and then 3 on the bottom, right, of these rectangles. But now, yeah, okay. So now on this back side, right, what used to be a full rectangle, erase some of these things. I've got too many lines. What used to be a full rectangle is now, well, it's cut in half, right? So we need to kind of cut this down to one of these. And where's my dang toolbar? Okay. Oh, come on. It's never easy. It's never easy. Okay, here we go. So now that rectangle has turned into this. So let's see. Let's start counting now that you've kind of seen what I'm getting at here. Oh, no. Oh, no. Oh, no. Chaos. We got, I can't switch between my pens fast enough. 1, 2, 3, 4, 5, 6 of the rectangles, right? Of the long rectangles. So I'm going to put that right up there. And then we have how many squares? We have 1, oops, let's see. I'm going to erase these markings just so that we don't get too confused. 6. And then we have 1, 2, well, interesting. Did I, let's see, what did I, before I get too far ahead of myself, I guess this is actually a pretty good time to talk about this. When I made this, counted these as 6, right? 1, 2, 3, 4, 5, 6, right? Does anybody have any arguments about whether or not that number is correct, strictly speaking? So this, these pieces right here, right, are squares, I would argue, right? So that would fall into this category, right? So there's 1 square, 2 square, right, for this, 3 square, and then maybe 1 back here on the side that we can't see, which we were just talking about. Right? But tell me something about, let's see, I'm going to try and leave only the ones that I'm interested in. Right? The bottom of this shape and the left side of this shape, I guess, considering that this, let's say that this is the front of the shape, right? So the left side of the shape and the bottom of the shape. What are those on the bottom would not be a rectangle? Okay, very good. And so I'm kind of getting at the same thing on the left side too, right? It's like a staircase. Okay, very good. Thank you, Brendan, right? It's like an L shape, right? So now we have a new shape introduced that looks something like this, right? That lives underneath here and back behind on this side, right? So let's account for those. I had counted these long rectangles, right, as one solid, a rectangle separated with a square next to it, but that's not quite right, right? It's turned into this new L-shaped thing, right? So there's 2 of these, oops, let's see, times 2, 1, 2. And then how many rectangles do we have? We got 1, 2, 3, and 4. Right? 1, 2, 3, 4. So how does this entire situation, right, this madness of numbers and lines that I've drawn all over the place, right? Let's see if I can capture all these and pull them over here. Right? Oh, cool. I can just kind of go off the screen. What does this look like? Well, I might suggest that, taking something like this and turning it into something like this, right, would be one way of doing it, right? But that's, again, only if we're accounting for the fact that these faces don't line up. So let's actually, let's take a look at this again with this one, right? Group practice, here we go. I've got my shape, and when we're separated like this, like I kind of drew them with the different colors, right? We have these 2 kind of disjointed faces, right? But you'll notice that when I click on these faces, I can highlight them, right? The thing about this, right? And same thing, let's see, with this one, right? These 2. Right? If I were to join these together, right, with an actual, in the flat pattern, the sheet metal model, right? What does this look like? Well, let's take a look at it in a new Part Studio, right? I'm going to open this up, quickly whip out a few rectangles, one by one. like this, 2 by 1. So this is 1. This is 2. Oops. So we've got our shape, right? Just like we started with. And I'm going to use my sheet metal model to turn this part into sheet metal. When I look at this, let's start doing exactly what we've already done before, right? So I need to click on this face, right? And let's say, well, what do we think? I can click on this face so that we kind of have this hat shape looking thing, right? With the L shape on the bottom right here, this rectangular face, and then this rectangular face with the topper on it. I can start building this one out here, but let's talk about something that that happens, you know, similar to how we had an issue with, maybe joining a face too many times, right? Something like this won't exactly work if we have a corner like this, right? What happens if we do something like, I don't know, would this break it? No. How can we make this not work? How can we break this? I found it. Collision in sheet metal flat pattern. Let's take a look at this. I'm going to take away all of these other faces. It took me a minute to get there, but let's take a look. So if I have these pieces, right, that are bent from this face. In fact, let me just do it like this. This will be easier. So I don't have any issue of being unable to unfold it, right? But this, what's the issue? Why is it saying that there's a collision in my flat pattern? And what's this all about, right? What's all this then? What's going on here? Why do we have this error that's called collision in flat pattern? Do you notice that if you were to unfold this rectangle, right, this rectangular face, let's see, I can draw on here. Yeah, cool. And this square face, right, this one's going to fold up like this, and the blue one is going to fold out like this. Right? And when they do that, they're technically going to be overlapping one another. So we have two things to consider, right? We don't want to overbind our folding patterns, right? By, creating a corner or something like that that is welded together. But at the same time, we need to make sure that we're not creating collisions when we're starting with a flat piece of paper, right? These two pieces on a flat piece of paper would not be able to overlap, right? You need two separate sheets of paper, and you need to tack some, use some tape to tape on a new extension of paper once you had this, right? So this this kind of strategy of looking at both of these, looking out for these two types of collisions, right? Something like this, and then something like this, right? Those are the types of errors that we can get ourselves into if we're not too careful about these flat patterns, right? So let's jump out of this and get back in here. Right? I'm going to, let's see, okay, so we had these parts. Okay, here Here we go. Let's jump into the last part of this workshop. Right, you'll have some exercises. I feel like actually getting your hands on some paper and just folding paper and actually making these shapes is a little bit more fun than just listening about how we can look out for collisions in flat patterns. Right, so I'll let you get into that here in just a minute. But I do want to bring your attention to the types of review games that I'm posting on the assignment this week. Right, there's going to be two types of games that you can, again, if they speak to you, then I encourage you to spend some time with them. Right, I don't want that to detract from also being able to do some flat patterns, right? So the first one is this this dice game, right? And the dice game is a lot like the shapes game with the actual shapes from the test. But effectively, what we have is we've got this, dice. We have a six-sided die, and we have a cipher that tells us what the pattern is, right? And I'll post this on the actual assignment itself, so you don't have to go back and forth between these tabs. But effectively, one of the things that we can do, right, especially since this one is such a this exercise really kind of forces you to get good at recognizing quickly, oh, this was a X rotation 90 degrees, or this was a Y rotation 180 degrees, whatever. But we're taking this and we're rolling it, right? I'm just going to click and drag randomly, right? Kind of square it up a little bit, and we need to figure out how we went from here to, or from the beginning to this one, right? And we can use that dice pattern. So it's going to be a lot of drawing squares, drawing the dot pattern on each of those squares, and then rolling the dice, as it were, to do that. And then you're going to say this had to rotate this number in the whatever direction, yada yada yada. We already did that something similar when we were talking about 1D and 2D rotations. The next thing, the other game that I want to show, right? And again, these links are going to be on the homework assignment itself. But the other thing that I want to show is this game, and I actually think that this may be more interesting, right? Because you're effectively making your own test, right? Your own test problems, and there are an infinite number of test problems that you can do. So when we do this, so I'm going to pull up two separate windows that show two different shapes of my my Onshape. Of my spatial visualization test, right? I'm first going to, and again, the instructions will be on the assignment. I'm going to start by cranking up the difficulty, right? Over here, hidden edges removed is an option that allows you to see the edges of each shape, but without any shading, right? Much like you see in the test, okay? Then I'm going to, start these off in an isometric view, right? Nice and square. And then I'm going to draw these on my sheet, right? On my graph paper. I'm going to transcribe their coordinates and whatnot onto a grid, both of them. And then I'm going to rotate one of them in some way, right? So let's say I ended up being right here, right? What do I need to do in order to do that? Well, I have a few things, right, to go off of, right? I've got this navigation cube, so effectively I need these navigation coordinate axes to line up at the beginning and at the end, right? So I need to do something like this. Right? And you'll notice that when I rotate this, right, I'm not rotating them necessarily along axis lines, right? And that's pretty hard to do in CAD, right? To just rotate it around the x-axis or around the y-axis. You can do it, but it's a little bit weird. But what it's really showing us is that we can rotate this in the same way each time this is what it'll look like, right? So we can play this game in multiple ways, right? We can do, rotate both of them and then kind of say, okay, this is the amount and the direction that they were rotated. Or you can do exactly like I said with in the spirit of the test, right? Oops. I can say if one shape, draw this shape at the beginning, draw this shape at the end, right? Then how does this thing rotate? Well, if it starts from here, I'm going to, in my mind, without actually rotating it on CAD, I'm going to draw what it looks like, and then I can check my answer by setting up the little navigation cube in the top right-hand corner as being the same. Okay. So those are going to be our kind of study games, right? We still have those all of the tools that we've used in all of the assignments before, right? You can always go access those. You have access to those assignments still. You also have access to the study guides that I've made in the past, right? The ones that we used last time to study for the exam. So, and those are a little bit more classic, right? They have the actual questions. This is just a little bit, hey, if this is something that, number one, interests you because it's more interactive, it's CAD, right? That's kind of fun. But also maybe it's a little bit easier for you to see, right? That how these shapes rotate in space, right? I always get a lot of complaints about this particular shape over here, and for good reason, right? It turns into really weird stuff when you rotate it like this. All of a sudden it's an envelope upside down, and it's like, what the heck just happened, right? Oh, well, it's just this thing, right? So you can keep the shading on if you wish, right, to help you out. You can even turn on this perspective view, right? Turn perspective on, and it kind of gives us this kind of look and feel for when things are close, they are bigger, right? And when they're further away, they kind of go and diminish back, which is more like what we're actually used to when we're looking at things in the real world, right? Which is kind of cool. So whatever suits your fancy, right? Again, you got one more assignment from me this week. I actually haven't posted it yet, but I will do that today. Tonight, and you can do that. But I will also unlock the second exam now, right? So again, make sure that you are aware of the fact that if you have not turned in all of the assignments, your grade will not be counted, right? If you take the exam and then finish off the assignments a little bit later, it's not exactly the way that I was intending for them to happen, but I understand, right? That's fine. Maybe you forgot to turn it in and you started doing the test or whatever, or maybe you just want to get onto it, right? But that's kind of your ticket in, right? As your ticket into another attempt at that 5% of your grade is doing the work and showing me that you have done that. And when you have all of those in your catalog, you'll have that 3% extra credit. So does anybody have any questions before I sign off for the last time today and say sayonara and good luck to you in your workshops. I see most of you all the time anyway, at least if I've taught some workshops with you. So I'll see you a lot more, especially as we approach Expo. But yeah, anybody have any questions, comments, concerns? I actually I just can't shut up, can I? I just asked you a question then, and I didn't wait for anybody to answer. But let's see. Maxine asks if there's a due date for the retest. I'm probably going to put it about a week and a half out, right? Take it when you have time, right? It's not really something that I'm too concerned about. As long as you get it done, get it done when you're not stressed out about anything else, right? So if you don't have tests this week or something like that, do it now. If you do, then, chill out and we'll figure it out, right? I'm not too worried about due dates. But I think at the very end of this thing, I would be extremely grateful. I'm going to make my own right? I don't have FCQs for this workshop. Thank goodness, no. But I don't have a formal way of asking you what you thought and some feedback from you, right? And so I'll probably make this like an informal Google form, or maybe on Canvas, I'll make a test or something like that. That doesn't count for any grades, but regardless, keep an eye out for that, because I would love to hear your comments on how certain things helped. Was it fun? Was it interesting? Did it become monotonous and tedious? Was it worth it for 3% of your grade, right? 5% of your grade, whatever. So keep that in mind. Keep an eye out for that questionnaire. I'd love your feedback, because this is kind of something that I've worked on for quite some time, but that doesn't mean it doesn't need some work, especially now. So can I talk to you about CAD after you? Absolutely, Ella. You may talk to me about CAD anytime. So with that, does anybody else have anything to add? Alrighty. Well, thank you all so much for your time and your effort. Right, I sincerely appreciate it, and I like seeing y'all here. So I'll sign you off. It sounds like we're going to stick around to talk about some CAD here for just a little bit, but you are dismissed.
Thank you. Thank you.
Thank you.
Thank you.
Yeah. What do you think, Ella?
Thank you.
All right. So I have 2 questions for you.
Yeah.
So I was watching your CAD level 2 videos, and so I got to I don't know if you have all this stuff memorized, but the cube that you originally built was 3 inches by 3 by 3. But at the end, when you put them together, it's only 1 inch somehow. So the screw doesn't, and the bolt doesn't fit through the object all the way.
See.
Does that make any sense?
Yes. There may have been a discontinuity in the way that I planned that out. Let's see. Let's take a look at that. Where's my CAD 2? Here we go. So I've got the top joint, got the bottom joint, right? And these are each an inch. Come on. Yeah, so that's an inch. Interesting. So I guess I need to re-record that section.
There's a chance I may have completely missed you changing the dimensions, but so then I was just confused how I would change it to make it 1 inch without messing up every other dimension.
Sure. No, I have a feeling that there may have been, I made these videos several times over, as I was producing them, just simply because I was, kind of going at it while I was, let's see, what did interesting. So I did change that to 1 inch. Did I do it without explaining it? Let's see. I don't 3 inches. Ooh. And no surprises there. That is the case. I don't want to listen to my own voice. I want to change my cube size.
Oh wow.
All I need to do now
so I completely
is go back to the cube, change it to 1 inch, and my changes will propagate through my part. Okay. Now, so one of the things about this, right? And let's just see if I can do this on the fly, right? If I were to go in here and I were to change this width dimension to 3, what happens there? Does everything go cattywampus? Well, looks like it's kind of okay, right? The assembly, let's see, it's mad at something. Top joint, what is it angry at? Seems to be upset. Well, that's fine back there. So certain features. Where is this part? Well, why is it tiny now? That's weird. Wait a minute. The top joint I just made. Oh, 3 millimeters. Okay. That's what the heck happened? Okay. So 3. inches. Oh, that's not even on the right one. Just a second. I forgot that I had made a different one called, where is it? Super cool part. No, that's not it. Recently opened. What the heck just happened? Where did my part go? CAD 2. CAD 2? CAD 2. Is this it? Ah, there it is. Okay, so this one's in inches. Here we go. So if I come in here and I change this to 3 inches, what happens? Does it break everything? Actually seems like it's happy enough. But yeah, everything's going to be bigger. And ultimately that screw, right? If I use the same size screw, it's going to be tiny, right? Which may be fine for the sake of, actually manufacturing what I'm doing. But like you said, yes, the length of the screw itself is going to change, right? And I could go back here and edit it, right? I would have to go back here and edit the standard content, right? So that it was, I don't know, 40.
40 isn't big enough though.
40 isn't big enough. Okay. Well,
so, okay.
And that's, I guess, not entirely surprising, right? This thing's pretty big for a tiny little screw like that. An M3 and M4 screws aren't very big. But yeah, there was just a quick thing where I guess I had changed it to 1 inch pretty discreetly. So yeah.
And then I have one more question.
Yeah.
Sorry, I'm like the lead CAD person on my project and I'm stressing out a little bit.
No, that's great.
So like we're creating how do I put it? Like a portable bus cleaner. So it's like almost like a box with like smooth edges, which I understand how to do. But is there a way I can like take out one of the sides of the boxes?
Okay.
Or of a rectangle?
Sure. Can I, let's see, will you share with me your Onshape document? My email address, so up in the top right hand corner, you can share it with mo.woods@colo.
I don't have anything yet though on it because I was starting tonight.
Oh, I see. Okay.
So, but I was just wondering if that's even like possible to do.
Okay. Let's take a look at it. So I've got my document right here, and I will share it with you. First things first. So
it'll be GA, because it's Gabriella.
Ah, I see.
Technically, yeah.
Yeah, GA.
ER. Yep. That's it.
Ah, there you go. Very good. So share, and actually, yeah. We'll make you the owner if I can. That's fine. Okay, so we have, let's say, a box, and you wanted to, I'm just going to make it 3 by 3 just because.
Yeah.
And let's say it looks something like this. Sure, I'll keep it like this. So we got this box right here. You're saying, can you take this face off?
Yes.
Okay, so there's a few ways to do it, right? I'm going to kind of unclutter my screen by hiding these things. I've got a couple things, right? One way, maybe the most obvious way, but not exactly the most rigorous way, is this delete part option. No, wait, let's see. Is there a way to delete? Delete. So actually, maybe it's not something that we can do in Onshape. I know that in other CAD, delete face, I see. So there's a delete face option right here where we can come over and click on a given face, right? And, oops, why didn't it like that? Delete face, leave open. Okay, so now we have this surface with this cavity in here, right?
Okay.
But the thing is that there's no difference between this on the inside and the outside, right? It's a surface. And so we've kind of broken the laws of physics. This is an infinitely thin box that is, so we can't really do that. So what I would say is maybe something that you should consider here is using the shell option. Shell, when you click on it, it asks you which faces you want to remove. Right? So if I choose this, it will ask me which faces I want to remove. In addition, it asks me how thick I want my material to be that actually kind of makes it up, right? I don't even actually have to select a face. I can say that it's hollow, right? And I'll select that this thing is hollow. And now I can't really tell that it's hollow, except for the fact that I know it's hollow. And just like in the CAD 2 workshop, right, you can use this section view tool to take a look on the inside, x-ray it, and okay, yeah, there we go. It's a hollow box that has been separated, right? So the shell tool is a more realistic way of accomplishing that, right? And again, I would think that maybe leaving one side open like that is what you're looking for.
Yeah, that's awesome. Thank you so much.
Cool.
I was
Good,
so
yeah.
confused as to if I could do that because like I tried to do it, but I got the first option that you did with just like the thin.
Yeah. Just the
Oh,
face. Yeah.
yeah.
Yeah. So and there is a place for that, right? Surfacing is a thing, but and arguably sheet metal is kind of part of that whole process too. But yeah, I would say that this is the way that you want to go. So cool.
Thank you so much.
Yeah, no problem. Thanks for asking me those questions. I appreciate the feedback too. So
Yeah, of course. And sorry about the not hearing the 1 inch change.
No, that's okay. I'm glad that was the case, right? It's good to have that kind of review of that content, because I'm one of those people. It's like once I make the video, it's like just post it. I don't want to watch myself do it again.
Yeah, no.
I could have been. So no, right on. Well, thank you.
Thank
and I'll
you.
see you around, Noah.
Have a good one.
You too.